This lesson is on the normal distributions. So sometimes we even call this the bell curve. That's kind of slang. We usually call it the normal distribution, but it kind of looks like a bell. Do you see that? Like the shape of a bell curve there. So it's a normal distribution. A lot of data ends up being approximately normal. In other words, there's a lot of data values near the middle, near the mean, and only a few data values on the outside. So a lot of times when you collect data, it's going to look like this. And so here's an example. The heights of various pine trees are normally distributed. That means it's going to be a bell curve. And the mean height is 33. So we're going to put that right in the middle here. So the mean height, this is like our mu here, our mean. Our mean is 33, and it's right in the middle. And our standard deviation is 3. We kind of mentioned this a little bit the last time. So we're going to add one standard deviation to the right. So plus 3, so this would be 36. And I'm going to keep going to the right. So this is now, this is going to be plus 2 standard deviations. So like that's 1 to the right, that's plus 3, another plus 3, so that's going to be 39. And then this would be plus 3 standard deviations. So if you get all the way out to here, that's going to be what, 42, I think. We're going to do the same thing in the other direction, but we're going to subtract. So if I subtract 1 standard deviation, that's 33 minus 3 is 30. Subtract 2 standard deviations, minus 3, that's 27. And minus 3 standard deviations, and that's going to be 24. And so pretty much almost all the data is between 24 and 42 here. Very little would be outside of 3 standard deviations of the mean. And we can even go further. We can say percentages here. So these are pretty much true. They're approximations, so they're not exact. But basically what this is saying is, this one is saying 1 standard deviation. So 1 standard deviation in each direction. So I go 1 to the right and 1 to the right, 1 standard deviation to the right and left. That whole area, so this whole area, this shaded area there, is 68% of the data. And then if you go 2 standard deviations, so if you go not 1 but 2 standard deviations to the right, that's going to be a total of 95%. Wow, 2 standard deviations on either side there. 95% of the data is going to be in that, I'll call it that shaded region. So I'm including everything there, right? And then if you go 3 standard deviations, almost all the data, 99.7. By the way, you want to kind of memorize those. I will let you use your notes, but you want to have those for your notes. In fact, I might even go a little further, but so you can see only after 3 standard deviations, there's like 0.3% of the data. That's on both sides, so 0.15% on each side. Very, very small amount of the data might be more than that. Let me say this a different way. So I'm going to kind of, let me kind of erase some of this. Maybe it'll look better. Okay, so I'm going to overlay this on top. Okay. So this is a different way of looking at it. You can see that 1 standard deviation is 34 plus 34 is 68. Add in this 13.5 and 13.5, that's another 27. That adds up to 95. And then 2.35 and 2.35 is like 4.7. So 95 plus 4.7 is 99.7. So it's almost more helpful. Maybe you should write this in your notes to see each little piece there is kind of that certain percentage. So sometimes it's really helpful. We'll get to some questions where we'll actually use that here in a second. So let's look at what those questions might look like. So here it says for a population of male European eels, wow, I didn't know there were American eels and European eels, the mean body length is 15.7 and the standard deviation is 2.8. So what you want to do there is the mean is 15.7. 15.7. Make this a little thinner here. Okay, and then so we're going to add 2.8 and subtract 2.8 to everything here. So hopefully I can do this in my head. If you can't do it in your head, you can basically just bring up a calculator And let me just bring that up so you can see it. So you can start with 15.7. One thing I like to do, I like to press enter. Then I say plus, I think it was 2.8. Let's make sure 2.8 plus 2.8. So that's 18.5. So 18.5 goes here. I'm going to add another 2.8. So that'll be 21.3. Add another 2.3. That's 24.1. And let's go the other way as well. So let's go back to, I just like to copy and paste here. So 15.7. I'm going to subtract 2.3, or 2.8, I mean. Hopefully I did 2.8 before. That's 12.9. And let's do that a couple more times. So that would be 10.1 and 7.3. Okay, so now the question, this kind of thing. So once we've got that, and you can draw the lines in here, that's totally fine to do here. It kind of breaks it up into those regions, which we'll need in just a second. So the first question says, approximately what percent of eels are bigger than 12.9? So let me kind of shade that. So we say 12.9. So I need this kind of shaded area here, right? So I need all of that. So there's different ways of doing this. I'll show you how I might think through this, and you can definitely think through this differently and still be correct here. So I think about this as, this was 34% of the data right there. And really, I think of the median as being the halfway point. In other words, everything to the right of, the mean being the halfway point, not the median. Everything to the right of 15.7, that's half the data to the right and half the data to the left. So all of this, so to speak, is 50%. 50%. So 34 plus 50, that's 84% of the data. So that's how I would do that problem. I would just say, well, rather than add up each piece there, and by the way, don't forget there's a little piece over there of like 0.15%, which would be easy to forget. And that's why I think it's easier to just think of it as 50% rather than add up each piece. And let's try this one. This one is a little different. Between 10.1 and 18.5. So 10.1 is here and 18.5. So I kind of want this shaded area all the way over to 18.5. So you want to think about that. Take care of this. Okay, so this one's 34. We know that. With those two are easy. These two add up to 27, so I think that's 13.5 or half of 27. And I think that's what we need, right? So 68 plus, let me get out the calculator here. So 68 plus 13.5, 68 plus 13.5, whoops. 68 plus 13.5, 81.5. So I think the answer is 81.5%. Would be in that shaded area or in between those. Notice how we're nicely picking values that happen to be 1. Like really, this is 1 standard deviation in each direction. This is 2 standard deviations each direction, and this one is 3 standard deviations. Those two numbers are 3 standard deviations in each direction. So typically with these kind of questions, we're going to be nice and pick values that happen to be one of those 6 values there. So I would write, if you're drawing a label, go ahead and go 3 standard deviations in each direction. Do one more, and I think y'all are starting to get this. I put a little twist on this one, so hopefully this one will challenge you and get you ready for a tough problem. So the heights of American males are approximately normally distributed with a mean of 69.5. So 69.5. Standard deviation of 2.5. So this would be, I think I can do this, 72, 75.5, 78, 67. When I subtract 2.5, 64.5, 64 by the way, 4, and 62 I think. And again, you might want to consider drawing the lines, kind of separating that out, because we might need that in just a minute when we get to the question. I'm guessing we will. Okay, so taller than 6 feet. So let's look at this and kind of shade it in. So 6 feet, oh man, we might do some conversion here. So 6 times 12 is 72. So we're really looking at 72. So taller than 72. So like all of this, all the way, even a little past, all the way to the very end there. So the different ways to think through this, again, these are easy. These are 34%. This is 34%. Those are probably the extra. That's 13.5%. That's, was it 2.35, I think. But really, I know from here to here is 50%. And so if this is 34 here, I'm just going to do 50 minus 34 is, what is that? So that'd be 4 minus 16%. So 16% of the data is in that shaded region. But there's a little twist to this question. I kind of glanced over it. I first found the percentage, which is what we've been doing. But this is a little nuanced. So in a group of 2,000 adult males. So I really want 16% of 2,000 males. We took a sample, right? They took a sample. And so they're kind of like going, well, how many of that sample of 2,000? So we need 16% of 2,000. So I might type in 2,000. Whoops. 2,000. I just multiply by 0.16 at 16%. And that should give us an answer of 320. So 320, I would expect out of, it's kind of interesting, out of 2,000 adult males, 320 would be above 6 foot tall, taller than 6 feet. So, in fact, I'm in that category. I'm 6 foot and 1/2 inch. So I'm barely in that category, just in there. So only 320 out of 2,000 are taller than 6 feet. Okay, that is your lesson for today. And again, we'll have a Q&A later before the quiz. So if you're having trouble with this section, please come to the Q&A and ask questions about the homework. Thanks. Have a good day.